Okay, so whatever Roman numeral you happen to be on, I'm going to call mine 5 because that's what's in my notes. The more important is the topic. So we're looking at decomposing functions. Okay? So decomposing functions. The idea of going backward. Composing, we took an f and a g and made them into a new function. So in this one, we're going to tear them down. Basically, I need you to do is I need you to think inside function versus an outside function. Inside function versus an outside function. So let's say I give you, I apologize, I'm going to change that thickness. There we go. So given h of x equals, let's say something like the cubed root of x squared plus 1. What two functions do you see? Say it again. Okay, so there's a third, so it's not a square, but it's a cube. So we have a cubed root is 1. And is that going to be the inside or the outside? Say it again. Definitely the outside. Because underneath that radical, we have what function? We have quadratic. Okay? So, when I decompose this, we simply say f of x is going to be, I don't care which one you call it, the inside or the outside function, f of x is going to be, I'm going to call it the cubed root of x. That would be the outside function. And then the g of x would be the inside, would be the quadratic x squared plus 1. Inside. Inside and outside.
It just looks like you go.
Side. Like it's inside the other. Sorry. So if we look at that like we did yesterday, we would say that h of x, we could say that h of x is going to be equal to f of g of x, with g of x being inside the f function. Okay, you try one. It shouldn't be too complicated. That will get more challenging. Let's try another one. Say you're given something like, something from geometry. Okay, we might as well start trig terms a little bit. So let's go the sine of 3x plus 1. And we'll call that h of x. Okay, break it down into its two functions. Okay? Ms. Latham, what's one function you see? The sine function, absolutely. So sine, we'll call that the outside one. Sine of x. And then what would be the inside function?
plus 1.
3x plus 1. So we have a linear inside of a sine function. All right, ready for a challenge? No? Yes? Ready for a challenge? Okay, here we go. Here's a challenge with a given. Let's go with cosine of the square root 3x squared minus 1. There might be more than 2 functions. Break it down into its single functions. See, most people, looks like they're almost done already. What is one function you see? Cosine is the outside function, it's the easiest one to see. Cosine of x. Okay? What's another function that you see? And we would call that like the middle function. We have the outside function is cosine. Middle one would be our square root of x. And then what's our inside function? A quadratic, 3x squared minus 2. So we would say then that h of x would be equal to f of g, and I just use the letter k of x. And we have a function inside of a function inside of a function. Quadratic inside of square root inside of cosine. Okay, now one of your homework problems asked us to do basic operations, and I wasn't really planning on going over it, but let's just go over one real quick one to make sure we understand what I was talking about. It's a little bit of review, you should have seen it before. Are there any questions on decomposing, or can we go on? You good with breaking it down? All right, so we're going to go back to, and it's actually I don't know what Roman numeral, we'll just go with Roman numeral 6. And that is operations on functions. So let's pick 2 basic functions. Let's say f of x is going to be, what's your favorite function? Linear, quadratic?
Quadratic.
Linear, or quadratic, okay. So we'll go 4x plus 2. You laughed at me. Do you not have a favorite function? Never been asked that before, have you?
No,
All right.
I have not ever been asked for that.
You should pick out which is your favorite function. Okay, g of x. Someone said quadratic, so let's make it x squared minus 1, something like that. Okay, so what's one basic operation? What's the first operation you ever learned? Addition. So let's look at addition. So honestly, when we start to add functions together, it's simply adding like terms. That's all it's saying. If I say f of x plus g of x, okay, all you're doing is adding like terms. We're doing 4x plus 2 plus x squared minus 1. And then combine like terms. Gives us x squared plus 4x plus 1. And you're just combining like terms. Okay, so after you learned addition, then we learned, okay, would you believe me if I told you there's no such thing as subtraction?
I remember you saying it last year. I don't remember what it's called though.
There's no such, do you remember? There's no such thing as subtraction. What you're actually doing is you're adding a negative number. Okay, because like 5 minus 2 really is 5 plus a negative 2. Yeah, so there's no really subtraction. So we don't really like subtraction, but we're going to put it in here anyway. It's simply like, it's once again, it's combining like terms. But this is a tricky one. I'll put a little asterisk by this one. If you're going to make a mistake, it's going to be on probably subtracting. So let's say we're going to do, and for simplicity's sake, I hope it's okay, I'm going to go ahead and erase this part. And I'm going to say, what if I have f of x minus g of x? Well, here's the tricky part. We have to think about this in parentheses. 4x plus 2 minus x squared minus 1. Because you're adding the opposite. Okay? And I have to take that negative and do what with it? I heard the word.
Distribute.
Distribute it. Okay? So what I'm really doing is 4x plus 2 minus x squared plus 1, because you have to distribute it to both. So be very careful when it comes to subtracting polynomials. And then, of course, you would simply have negative x squared plus 4x plus 2. Combine like terms. Okay, so then you learn adding and subtracting. You did this for first, second, third, however long. And then along around, what, third grade, they gave you what? Which is just adding quickly. Multiplication is just a shorthand for adding. Okay? So, what happens if I multiply these two together? What if I say f of x times g of x? Now, another way to write this one I showed you yesterday is f g of x. And I don't like that notation either. I'd rather just say f of x times g of x. All right, and what skill did you learn in Algebra 1 to help you multiply these two polynomials together? What's it called? Say again. What did you say? I can't hear you. My ears are stopped up today. It's very humid and my ears are closed in, so imagine having water in your ears. Say it again. Okay, FOIL or distributing or whatever method you use. Sometimes it's a box method. Okay, something like that. Okay, so I'm just going to FOIL it. Make sure you do it. The other day on the quiz, we had two trinomials, and some of you didn't FOIL it. You just like multiplied the first two and the second two and the third two, or you did some weird thing. You have to multiply to distribute 4x to every single one of them. Minus 4x, you distribute 2 to every single one of them. Then, of course, that's a good answer. A better answer is to put them in order. So 4x cubed plus 2x squared minus 4y minus 2. That's an x, by the way. Minus 4x. 1. So whatever method of multiplying, distributing, whatever. Would you believe me if I told you that there's no such thing as multiplication?
Yes.
You wouldn't believe me? Shame on you. There's no such thing as multiplication. You're actually, no such thing as division, sorry. No such thing as division, sorry. In my head I got it wrong. So there's no such thing as division. You'd believe in that, right? Because you're simply multiplying by, not the negative, but the inverse. So like dividing by 2 is the same thing as multiplying by 1/2. 10 times 1/2 is 5, 10 divided by 2 is 5. Okay. So last one is going to be dividing. A little different one on this one. You'll see things like f of x divided by g of x. Probably the best way to notate it. I think your book does f of x divided by g of x. Simply because of formatting. So how am I going to divide these two? So I would have 4x plus 2 divided by x squared minus 1. How would I divide these two? Say it again. You can't cross anything out unless it's a common factor. So first thing would be to, say it again. Yes, so we're going to factor, and the bottom is difference of 2 squares. So on top, I'm going to go ahead and factor out a 2, 2x plus 1. On the bottom, we're going to factor the difference of 2 squares. Does anything cancel top and bottom?
X plus 1. Or, no, I lied.
X plus 1 is not canceled.
I lied.
You
Did I
lied to
just
me?
say that?
That's it. I'm done. Can't trust you ever again. Okay, yeah, so nothing cancels here, right? So there's one thing I have to put in here. We talked about it yesterday, or the day before, whenever we were here. We have to say that x cannot be equal to what values? There's one thing you have to have. Not 0. 1 and negative 1. Plus and minus 1. Because if x is 1, 1 minus 1 is 0, the denominator is 0. If x is negative 1, negative 1 plus 1 is 0, the whole denominator is 0. So you're right in saying 0, it's just the denominator is being 0. So whatever values make that denominator 0. And that's really all you have to do is just put that domain restriction on it and you're good. All right, that is lecture 14, we're done. Lecture 15 will start on, you guys do realize when I say yesterday, I have pre-calculus every day. So if I say, we did this yesterday in class, I actually did, but you didn't, so just forgive me. I'm not lying to you, I'm just screwed up. Okay. So lecture 15, we're gonna talk about inverse functions. We're gonna bring back in what are functions, what are one-to-one functions, and then do inverse functions. Are you excited?
Yay.
That'll be on Tuesday or whenever we have class again. Right now, it's time to work on some homework.
Yay, homework. At least I don't have to do it at home.
Evan.
That's kind of the idea.
Can I see your notes, please?
No, because like I literally did not focus when I